This is lesson 5.3. It's concerning special parallelograms. In the previous lesson, we looked at parallelograms in general. Now we'll be looking at a few special cases of parallelograms, ones that most of them you're pretty familiar with. Just to remind you, here are the properties of parallelograms, the four main properties that we were talking about. Opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect each other. Those are the general properties of parallelograms, and so these special parallelograms that we'll be looking at also have these four properties. Okay. They also have these four properties in addition to a few more. So you want to make sure you remember these properties or have them in your notes because they'll just be added onto with our special parallelograms. These are the special parallelograms. Aren't they so special? Rhombuses, rectangles, and squares. Rectangles and squares you're pretty familiar with. Rhombus you most likely are aware of, maybe not as common though. So a rhombus is a parallelogram with four congruent sides, so all of the sides are the same length. A rectangle is a parallelogram with four right angles, right? The opposite sides are the same length, but not all four sides. But all of the angles are the same, and they're all specifically right angles. A square is kind of a combination of a rhombus and a rectangle. It's a parallelogram with all four congruent sides and four right angles. Okay, that's what defines a square. So those are the three cases of special parallelograms that we'll be looking at. So here are the properties of a rhombus. As we said, it has four congruent sides, and just like a parallelogram, opposite sides are parallel. Specifically for a rhombus, the diagonals are perpendicular. So when the diagonals bisect each other, they're actually bisecting each other at a right angle, okay, at 90 degrees. And also the diagonals bisect a pair of opposite angles. So from one vertex to the other, for the diagonal through the rhombus, it's actually bisecting or cutting that opposite angle in half. The properties of a rectangle, there are four right angles in a rectangle, and as we said, and the opposite sides are parallel because it's a parallelogram. And the diagonals in a rectangle are congruent. Okay? So the diagonals, both of them, are congruent to each other. They're going to be the same length. The properties of a square are the combination of the two. All four congruent sides, all four right angles, opposite sides are parallel, diagonals are perpendicular, and diagonals bisect a pair of opposite angles. And the diagonals are congruent. You see how it has all of the properties of parallelograms, rhombus, and rectangle. And so if we were to kind of map out what's the relationship between these different shapes, it would look something like this, right? The parallelograms is kind of the umbrella term, right? It's all of these shapes together. And then you have rhombuses over here with four congruent sides, rectangles on the other side with four right angles, and then they cross over as a square, right? So if you have a rhombus where all of the angles are right angles, that's a square. If you have a rectangle where all the sides are equal, that's a square. And so you can kind of see the relationship between these different shapes. But it's important to remember that they are all parallelograms. Okay? They're all parallelograms. And all parallelograms are quadrilaterals, right? Kind of seeing that relationship between all these different shapes and terms. So let's look at one example where we kind of put these properties of special parallelograms into use. This is an example where we're just focused on a rhombus. You can look at your notes for another example for a rectangle. So if we're looking at this figure here, right, we have this rhombus, A, B, C, D, and we're given one angle, like one half of an angle actually, and then we're told to find all the measures of all the other number angled here, 1, 2, 3, and 4. So we're going to use our properties of rhombus in order to figure out what are these different angles inside of this figure. Let's start with angle 1. The measure of angle 1 is going to be equal to, what's it going to be equal to? Well, if we look at angle 1 is right here. It's at the intersection of those two diagonals. And if you remember from the notes, the diagonals of a rhombus are perpendicular to each other. So if they're perpendicular, that means they're forming a right angle right here. And so that makes the measure of angle 1 90 degrees. And that's because those diagonals are perpendicular to each other. In the notes, I write that out so you can see that, but here in the video we can kind of talk through that. So the measure of angle 1 is equal to 90 degrees because these two diagonals are perpendicular to each other. That's what happens in a rhombus. The measure of angle 2, what is that equal to? That one requires you to remember something actually from our previous unit, where we talked about all the different angle pair relationships. So here we have 61 degrees, and we have this diagonal, right, that's cutting through here. Well, because this is a parallelogram, right, a rhombus is a parallelogram, we have two parallel lines cut by a transversal. And if you remember from our last unit, when we have two parallel lines cut by a transversal, we know some specifics about the relationships of the angles. So if this angle is 61 degrees and this angle 2, if you remember, those two are alternate interior angles. Okay, those are alternate interior angles to each other. Those are alternate interior angles to each other. And if you remember, between parallel lines, alternate interior angles are congruent. So if this is 61 degrees down here, it's also going to be 61 degrees at angle 2. Now let's look at angle 3 next. Okay? So the measure of angle 3. Okay? So the measure of angle 3, if you notice, is half of this angle right here at A, right? Because this diagonal is bisecting this angle. How do I know that? Because that's a property of a rhombus. The diagonals bisect the opposite angles. So if this diagonal is bisecting this angle right here, and angle 2 is 61, then angle 3 also is going to be 61 degrees. Because that's what bisect means. It cuts it in half. So this angle over here is the same as this angle over here. So again, using the property that says that the diagonals bisect opposite angles, if I know that 2 is 61, I can also say that 3 is 61 because it would be the same. All right, now last is 4, okay? And 4 requires a little bit more effort than the others. So there may be multiple ways of figuring out 4, but probably one of the easiest at this point is now that you know what angle 1 is and what angle 3 is, if you notice, and let me clear this up for a little bit, we have a triangle here. Right? When the two diagonals are crossing each other, it ends up forming a triangle with those three angles. So if we know that angle 1 is 90 degrees and angle 3 is 61 degrees, then we can figure out the fourth angle. Because all triangles, all of their interior angles add up to 180 degrees. So the measure of angle 1 plus the measure of angle 3 plus the measure of angle 4 is equal to 180 degrees. Right? That's because this is a triangle. So here, we're not necessarily using a property of a rhombus, but we're using our geometric kind of skill of being able to identify these different shapes here. Okay? So in this rhombus, when we have these two diagonals crossing each other, we see that it's actually forming triangles. And if you can identify that, then you can start to work with the angles inside of that. So the measure of angle 1 is equal to 90. The measure of angle 3 is equal to 61, and we don't know the measure of angle 4 yet. So there I set up my equation, and I'm just going to solve from there. So 151 plus the measure of angle 4 is equal to 180. The measure of angle 4, if I subtract 151 from both sides, I get 29. So the measure of angle 4 is 29 degrees. So these are all of the answers here. The measure of angle 1 is 90, 2 is 61, 3 is 61, and the measure of angle 4 is 29 degrees. Okay. And so in that, in some of them I'm using the properties of rhombus, so I need to know those, or at least have those in my notes, so I can compare them. And some of it, I'm kind of analyzing the figure here and determining, like, okay, I've got some triangles in here. What's the relationship between their angles? So sometimes you're going to have to think through it a little bit of what's going on here. But that is a way to approach this type of problem, is using the properties and any other geometric knowledge that you have to look at the relationships between these angles.